Hi, everyone. So today we are continuing to talk about applications of derivatives. The lesson title today is Interpreting Derivatives in Applied Contexts. Really, all that means is real world type situations. Like when I give you a scenario and start talking about a derivative, do you understand what that derivative is talking about in that context? Okay. So let's just review quick here. What is it exactly that a derivative is designed to do? What information does a derivative give us? The biggest connection I want you to make here is that a derivative is a rate of change, and I'm trying to emphasize that word rate because every time you talk about a derivative, you should be talking about it as a rate. Okay? The other thing you'll want to know about derivatives, the other really useful thing about them, is that we know that when a derivative, so f prime, is positive, that tells us that the original function, f of x, is increasing. And then vice versa for decreasing. So when the derivative is negative, then we have a decreasing function. So anytime you see a question in any context that asks you whether something is increasing or decreasing, that is a signal that you should be looking at the sign of the derivative, positive or negative. Okay, so let's take a look at this first example here. I'm creating homework packets like there's no tomorrow. All right, I'm just sitting in my room and toiling away creating these homework packets. We're going to let P of W represent the number of packets, and I'm going to highlight this word number. Okay, you'll see why in just a second. In the Wth week of school. Okay, so when I see P of 2 equals 3, thinking about how this function is designed, let's talk about what that means. I'm going to automatically start with what does the 2 mean, right? So in week number 2, and the 3 would represent the number of packets created, right? So I'm just going to say Mrs. T creates 2 packets. So again, that function is talking about the number of packets, right? Pretty straightforward. I could have asked you that last year. I could have asked you that in Algebra 1. But now let's talk about what the derivative would mean in this situation. So P prime of 8. Okay, so let's start the same way. This is talking about week 8. So in week 8, and then the derivative is always talking about how this thing is changing, right? It's the rate of change of whatever the function is designed to talk about. So I would say something like the number of packets, because that's what the function is telling you, is changing how? Well, this is positive, so I'm going to say that it's increasing by 2 packets per week. That is the type of answer I'm looking for in a question like that. So let's talk about the pieces that it contains. First of all, it gives you the time, right? It gives you the when. When is this happening? What is it that's changing? And that you can always refer back to, like, what is the function talking about? How is it changing? And then talk to me about the actual number, right? And make sure to put a unit on that. People try to reword this on me all the time. And I don't know if you feel the need to, like, put it in your own words or something like that. But this answer is exactly what I'm looking for. So if you're going to come to me and say, like, well, would it be okay if I say this thing or that thing? I mean, sometimes, right? Depending on what you say, like, there are definitely some things that could be acceptable and there's some things that would not be acceptable. But this is perfect. So just say it like this, okay? And some of you will say it in a way where it sounds to you like it's saying the same thing, but it's a little bit different. So for example, you want to make sure you're talking about what is happening right now. It's an instantaneous rate of change. You don't want to be talking about the future. You don't want to be talking about the past. So you don't want to be saying, it's going to increase by 2 every week. okay? Because we don't know that that rate is going to keep up for every week. This is only what's happening right now. You don't want to say it's been increasing up to week 8 because this number doesn't apply to anything except right this minute. I don't know where those balloons came from, but hooray. Anyway, maybe it's just sick of me ranting and wants me to stop, but that's the idea here. Okay. Does it make sense for P of W to be negative? So remember, P of W is talking about the number of packets. And no, that does not make sense to be negative. No. There can't be a negative number of packets. That doesn't make sense. Sorry, trying to write as fast as I can here. These wordy lessons get me in the videos. So, but does it make sense for P prime of W to be negative? Well, that could definitely be negative, right? A negative rate of change is just telling you that you have a decrease going on, right? So yeah, you absolutely could have a negative derivative. And I would say something like, well, this means the number of packets is decreasing by however many per week, whatever that negative number is. But it just means that I'm slowing down, okay? So I would have a negative derivative in, say, December, when I've sort of given up on things and I'm done making packets until after Christmas. Okay. Or at the end of the year when we're all about to take the AP test and I feel like I've given you all the homework packets I possibly can, I would probably have a negative derivative. I'd be slowing down. Okay. Okay. So example 2 is similar, but at the same time not. Okay. Take a second and read example 2 here. See if you can identify what the big difference is between example 1 and example 2. Example 2, the A of t function that you're given represents a rate. And that is a big difference from the last question where the function we were given represents a number. And when you're reading one of these word problems, that is the very first thing I would try to identify. Okay, are we talking about a rate? Or are we talking about a number? So it's almost like this thing, let's see, I need some other colors here, is already a derivative because it's a rate, right? This would technically be the derivative of the air pressure if we had that as its own function. So if I was just like measuring the air pressure at given times, okay, if I was making a table of all of the air pressures and taking some measurements, that's what I'd be finding here. Okay, and then if I took the derivative of that, that's what this A of t function is talking about. So when I do this interpretation, I need to remember that this A function is talking about a rate. So I'm interpreting it similar to how I did this one up here. I'm going to say at, this is in minutes, right? So at 4 minutes, what are we talking about? The air pressure, right? Sorry about that, pressure is changing how? Well, it's negative, so it's decreasing. By 3 psi per minute. Okay, so in this context, when I ask you to take a derivative, you're taking a derivative of something that's already a rate. So we're going to treat this like a second derivative, right? And anytime we take a derivative, we are saying, how did this thing, which is this up here, change? So for this justification or explanation, I'm going to say at 4 minutes, now we have to remember, what was A talking about? A is a rate. So the rate that the air pressure is changing, sorry to give you so many words here, is, this is negative, so I'm going to say decreasing by, now think about your unit here, decreasing by 2. The rate would be measured in PSI per minute. And if we're saying how much that's changing by, that's decreasing over time, that would be PSI per minute per minute. Okay, so my rate is PSI per minute squared. So you really have to take your time and think about what is the function talking about before you do your interpretation. Okay, for the next example, I would really like to use Desmos. So I'm actually going to switch over and use my other computer monitor. So I'll just start a new video for that, and I'll do the next 2 examples on a second video. So we'll see you in a bit.